Welcome back to Limits in AP Calculus AB, everybody. In this video, we're going to, if you remember from last one, we actually introduced the concept of infinite limits, and I gave you guys a couple of examples of possible limits you might be asked to evaluate. So in this one, we're going to actually talk about what infinite limits are and how we can get answers like those with numbers like infinity. So let's say we have a graph here that's given to us y equals x squared, or f of x equals x squared, whichever one you prefer. But as you can see, if you were to take the limit as x approaches infinity, well, you don't really have a defined value for that, right? This arrowhead right here signifies that the graph will keep on going as long as the x value or the y value are within the domain and range respectively. In this case, the x value can be any real number, so the y value can also be any real number, right? So what would the limit, as we'll say, as z approaches infinity of, x squared be, right? What would this limit be? Because infinity squared is just infinity, right? Well, that's the answer, right? That limit is going to be at infinity. And why is that? Well, if you take a look at the graph, like I just explained, this arrow tells us that the graph will keep on going as x increases. So if you were to, make increments here along the x and y axis, and if you were to increase your increments and keep on going, right, if you were to increase your x-axis, well, this value right here, this y value, that the xy coordinate, to say, that value would also keep on increasing, and at some point that y value would keep continuing, right? That would be an infinite value, which is why this limit would be evaluated as infinity. So that's what the concept of an infinite limit is. Now, we'll try to attack this from the viewpoint of an actual equation limit. So if we have, f of x is equal to x squared over 4. Let's say we do not have the graph for this, and this would be maybe an AP multiple choice. So what is the limit, as we'll say, in a approaches infinity of f of x? Well, if you were to just plug in infinity, well, actually, let's call this x. As x approaches infinity, well, this just becomes infinity squared over 4, right? And what is that? Well, that's still infinity. Because even if you're squaring infinity or dividing it by some value such as 4, 5, even 100 or 1,000, the infinity squared is still going to be so much more larger than 4, right? It's like taking, 10,000 squared and dividing that by, 0.1, right? You're dividing it by a value that is so small it doesn't even make a difference in the case of infinity. Which why in this case, instead of getting some numerical value over here, we're going to get infinity. Now there are cases where the limit as x approaches infinity is not infinity, and we'll go through one equational problem like that. So if we have our function f of x is equal to, we'll reverse this one and say 4 over x squared. Well, what is the limit as x approaches infinity? Oops, wrong notation. What is the limit as x approaches infinity of f of x now? Well, now that we have reversed the numerator and denominator, we get 4 over infinity squared. Now, if you were to think of this in terms of an example like this, let's draw a quick thought bubble right here before we evaluate the actual limit, right? You have some value, like 4, over some incredibly large value. We'll just, draw a bunch of zeros here, right? Well, what does that get closer and closer to? What does that value approach? Let's think of this in a much more easier way. So really, when you're doing this on the AP exam, you don't want to draw this thought bubble. You can most likely just evaluate the limit right there. But if we were to take, let's say, 1 over 10, well, that gets us 0.1. What if it was 1 over 100? Well, that gets us 0.01. What if it was 1 over 1,000? Well, now that just gets us 0.001. As you can tell, the number of zeros are increasing, and this value becomes smaller and smaller. So if our denominator is approaching an infinitely large number, you're dividing 4 by an infinitely large number, and that's going to get you infinitely close to 0, which is why this limit would be evaluated as 0. You're doing 4 divided by 999 trillion, 909 million, 999 billion, and some really, really, really large number like that. In which case, that value is going to get closer and closer to 0, right? 4 divided by 900 billion will probably be 0.0000000 all the way to like the hundreds place or something, or like 100 zeros, excuse me, and then a 1 after that. But that value is considered so small in mathematics that you can just evaluate this limit as 0 because it approaches that value. And this is where infinite limits intersect with regular limits, right? So the limit idea, the idea of a limit, is you're finding an approaching value, right? If you were to take the limit of any value on our y equals x squared graph, you're finding the limit as x approaches a certain value of that function. So in this case, the limit is just approaching 0. And that's what infinite limits are. So this seems a little complicated, but in order to solve a problem like this, if you ever see limit as x approaches infinity of f of x, if you have any function, all you really want to do is go ahead and just plug infinity in. Now we'll cover one final tip really quickly. So instead of basic problems like this, you might have something like x to the 5th over 5x to the 4th, right? Well, in this case, it's not as hard as it seems, right? Even if you plug in infinity now, you'll get something like infinity over infinity. And could you really consider that as 1, or would that still be some random infinite number? Well, before you even do that, you want to make sure that in cases like this, your function is as simplified as it can be. So x to the 5th divided by 5x to the 4th can really just be simplified to x divided by 5. And if you were to take this limit as x approaches infinity, well, that's really just infinity, right? Because you can cancel out an x to the 4th here and an x to the 4th here to get an x on your numerator. Now, there will be problems where you have some more complex equations like that, and we'll try going over one of these in the next video. Now, keep in mind these can still get much more complicated than it seems right now, based off a video I'm doing, because you can end up with limit as x approaches infinity of something like sine of x. How do you calculate that? Because if you recall your sine graph, it's just an oscillating curve, right? So as x approaches some infinite value, how do you determine what value this is approaching? Well, we'll tackle some stuff like that in the next video, and we'll promptly do this through a couple of examples before moving on to the next concept.